Make your own bacteriophage in 3D. Bacteriophages are probably the most common germ on Earth, and are known to infect all living organisms. Here is a tutorial on building its 3D structure. Starting with about an arm's length of wire, measure 3 cm segments to form triangles. Our goal is to build the bacteriophage's head using these triangles to form an icosahedron. An icosahedron is a 3D shape made of 20 triangle faces. Once you have your starting segments, form the first triangle and twist the wire around to lock the shape into place. Twist and thread through both ends to lock the first triangle. Then proceed to measure 3 cm segments for the next triangles. The trick to making an icosahedron easier is to make 10 triangles along a line first. Lock the second triangle by twisting under, then looping through the triangle. Here, wire management is important as you'll be threading the wire through often. In this orientation, proceed to make the next triangle going upwards. See how the triangle points to the right? You'll make alternately pointing triangles along this line of triangles. Thread the wire through the angle, then loop over to lock. Then twist around the other side to anchor the triangle to place. Continue to make triangles along a line. Thread the wire through the previous triangle, then loop over its side first, then the side of your recent triangle. The alternative to making an icosahedron in wire is to start with a pentagon, then building equilateral triangles on every side. Once you have that star shape built from that pentagon, you then connect the triangles to one another to form the next pentagon. The advantage of building triangles along this line is you can better secure joints of the shapes. So the count has to be 5 3 cm segments of each half side along this line. At this point, see how there are 4 segments on the right, and we're forming the 4th triangle on the left? Lock this triangle to place. Measure a 3 cm segment which you'll bridge to the start of the line, to form the 5th triangle. This creates the pentagon I mentioned earlier. See how it looks like a pair of pentagonal rings connected by triangles? Once done, make more triangles, this time along the sides of the pentagon. The goal here is to intersect all 5 points of the pentagon to meet at a center point, forming 5 triangles at the top. Thread the wire through and lock to place. Bridge over to the next vertex of the pentagon to form the next triangle. Once secure, you'll meet this line to the tip of your last triangle, at the center point. See the intersection at the center? From this center, bridge back to the pentagon for the next triangle. Once this triangle is secured, bridge over back to center to form the fifth side. Loop under and through the center intersection. Loop over the other sides to anchor the line. Then bridge back to the other side of the pentagon, the original side we started at. Once locked to place, you can bridge down the pentagon to intersect the free triangle. This forms the ninth triangle along the line. Bridging over to the opposite end closes the 10th triangle of the line and forms the bottom pentagon. See how when flipped over, it looks like a goblet? With the free ends, repeat the same process as before. Build intersecting lines from the vertices of this pentagon to form 5 triangles. And once complete, that makes a total of 20 triangle faces for this 3D shape. Here, you see me bridging a free end towards the center. This allows me to easily intersect a vertex of the pentagon. That makes 3 of 5 done. Once secure, I check around the shape before closing the remaining 2 sides of the pentagon. Since I ran out of wire here, I hook another wire at a vertex and twist around to anchor into place. I twist tightly around the hook to secure the line. I twist around a few more times past the hooked portion, then straighten the line. Now, I can proceed to close the remaining free vertices into triangles. That's basically the rule of the icosahedron. Each vertex has 5 branches. This forms pentagons and triangles. This last 3 cm segment then closes the 3D shape, forming the last 2 triangles. Once secure, bridge over to the bottom center point or vertex marked by the remainder wire. Connect to the bottom vertex and secure into place. This was where foresight was key. 23 cm segments means 60 cm of wire. Then bridging over requires at least 20 to 30 cm of wire, hence about a meter's length is needed. Once this free wire is secured, we have a complete regular icosahedron with 3 cm sides. The icosahedron forms the head of the bacteriophage, which contains the genetic material of this virus. Can you appreciate the 3D structure and its triangle faces? We can proceed with the neck or collar of the bacteriophage. Measure 12 2 cm segments and bend accordingly. Use these segments to form 6 branches radiating from the center. These branches will form the support structure of the collar as well as the spikes on it. With all 6 done, twist around the center axis line, then evenly space the 6 radiating branches. Proceed to loop over the branches by going around. Loop around tightly to better secure the spacing of the branches. Go around 2 to 3 times to widen the collar portion. Looking at the footage, if you make the branches longer, you can make a jellyfish with this design. Keep going around the branches to form a widened collar. If instead of branches, you made a ring at the bottom, you can turn the icosahedron to a jewel. So many possibilities with this build. See my Signet Ring quick tutorial for the ring portion. This step is also very similar to my other tutorials like the DIY sunflower level 1, where the spikes here turn into the sunflower's petals. Once complete with the collar, thread through a loop over to better secure the collar shape. Here you see me struggling with threading the wire through. I use pointed forceps to create a gap so I can more easily thread the wire through. I can then secure the free wire along the bottom of the collar. Twist and bend the branches of the collar towards the bottom. For some viruses, you can stop here and this collar will be their base plate and spikes. However, for this design we will proceed on. Continue to spiral down the center to form the sheath of the bacteriophage. I attach new wire to the ring of the collar, so I can extend down the line and create the spiraling sheath. This sheath covers the tube where the genetic material of the virus will pass through once it injects its infectious material. I create a hook with the new wire to anchor it to place. Once done, simply but tightly spiral down the line. If you look at it like a jewel, it looks like a mage or sorcerer's wand or magic staff. Rather than twisting the wire around, I rotate the virus around its central axis for a faster spiral. Continue to extend the sheath to about 6 centimeters. Here, the wire is strong enough to hold the icosahedron vertical. You can add a thicker gauge wire or a paper clip or stick inside the tube to make it more rigid and vertical. I twist the spiral through the loop once to lock the spiral to place. Forming the base plate and spikes is similar to forming the collar at the neck of the bacteriophage. Here, I make the radiating branches longer, out of 3 cm segments instead. Create 6 branches from the bent segments, secure into place. Twist around the center line, space evenly the branches, then loop over to lock the spacing. Loop over as close to the base of the branches to best secure the spacing. Here you can better appreciate how the radiating branches can easily be turned into petals for a flower. But as with the collar, these are spikes in this build. Keep going around the branches for 3 to 4 times around to widen the base plate of this virus. Once done, thread the wire through the loop over, then return to the center line to secure the wire. Fix the spacing of the spikes once secured. With a separate meter length of wire, create a 3 cm segment followed by a 5 cm segment. At the bend, loop over twice to thicken the joint of these 2 segments. Then bend back to the starting bend. Twist around the start to close this piece. Replicate this piece 6 times. These pieces form the tail fibers of the bacteriophage, the longer leg-like pieces of this bottom half. The tail fibers allow the virus to recognize its target host. The spikes on the base plate or tail pins also bind to receptors on the host cell. Once attached, the bacteriophage then weakens the cell wall of the host cell, and the tail sheath contracts to then inject the tube portion into the host. Then the viral genetic material is injected into the host where it can replicate. Continue forming the tail fibers. Let's skip ahead a bit. With all 6 done, attach the tail fibers to the tail sheath center axis. Similar to the neck collar and base plate, secure around the axis, then loop over the radiating tail fibers at least once. This gets a bit tedious at this point, because of the many protruding parts. Patience is key. Secure tightly at the base of each tail fiber leg, then around the center axis. Here I can spiral around the axis towards the base plate end. After trimming the excess from the base plate, I spiral back above the plane of the tail fibers to close the tail sheath. I thicken the sheath at the intersection with the tail fiber legs. I thread the wire through the loops of the tail sheath. And then I spiral back down towards the base plate or bottom end. I spiral tightly down until I can finally lock and secure the remaining wire. This step is key to ensuring your bacteriophage can better stand on its own. I thread through the layer of the tail fibers to lock the spiral from before. Then spiral around the base plate axis. Once I reach near the end, I fold over the tip of the excess wire, then lock the spiral. I press down with forceps to secure the anchor. Once done, I readjust the tail fibers down and make final adjustments. See how it can stand on its own? Viral Bacteriophage 3D, in wire. Can you appreciate the icosahedron head, collar, tail sheath, tail fibers, baseplate and spike? Use the icosahedron head design and the tips and tricks here to make jewels, rings or wands. Or make a virus for a science project. Just have fun with it. Like and subscribe for more designs and tutorials. Thanks for watching.